Some of the hardest problems in the world exist far above the planet. Our job? To launch the smartest solutions, to protect our satellites, clean up our clutter, to propel breakthroughs in propulsion, to learn more about our place in the universe, to outpace emerging threats. Every day, the Aerospace Corporation uses the latest technologies to ensure our nation's safety and leadership in space.
Hi, and welcome to the Space Policy Show. As always, you can find us on Twitter using hashtag the Space Policy Show, and you can engage with us on Vimeo using the chat box. We would also love it if you would sign up for our news alerts at aerospace.org/policy. Today's episode is really interesting. It's about missile taxonomy with Steve Dunham and Sam Wilson. Some of you have probably seen Sam on our show before. Ballistic missiles follow a parabolic trajectory, but how do you classify missiles that aren't just ballistic anymore? What about glide vehicles? What about missiles that are maneuverable? Join us today with Steve Dunham and Sam Wilson to talk about a new way of thinking about missiles, a new taxonomy that will inform future decisions and strategic thinking. Steve Dunham is a senior project engineer for the Aerospace Corporation Strategic and Global Awareness Directorate, also known as Project West Wing. Steve has 30 years of applied missile and launch system technical analysis experience in support of a variety of programs. Sam Wilson is a policy analyst at the Aerospace Corporation Center for Space Policy and Strategy, where he leads work on international space, nuclear command, control, and communications, and missile issues. Prior to aerospace, he was senior analyst at the Defense Capabilities and Management Division at the U.S. Government Accountability Office. Over to Sam and Steve to jump right in.
Thanks, Rebecca. Hello, everyone. My name is Sam Wilson. I'm with the Center for Space Policy and Strategy. And today I am with my friend and colleague, Steve Dunham. Steve, how are you?
I'm doing great, Sam. Thank you.
So today we are going to discuss a paper that Steve and I wrote, which we released a few months ago about the missile environment. It was a paper in which we propose a new taxonomy for considering the missile threat. We're also going to show some really cool animations today. Steve, how long have you been working on missile issues at Aerospace?
25 years or so, but I'm a fairly quick learner.
That says it all. I think this is going to be really fun. Today's going to be a treat. So, Steve, I want to start off by reading a couple of quotes. I was recently preparing for a presentation, a panel at CSIS about the hypersonic missile debate. And in looking for quotes describing hypersonic glide vehicles, I came across some quotes that speak to common misperceptions that exist about the broader missile environment. The very types of misperceptions that underscored why we needed to write this paper. So this first one is from the Congressional Research Service. These are all from highly reputable sources, including one where I spent the majority of my career. So this one's from CRS. Unlike ballistic missiles, hypersonic weapons do not follow a ballistic trajectory and can maneuver en route to their destination. This one is from National Defense Magazine. The big difference between a traditional ballistic missile and these hypersonic boost glides is the trajectory and the ability to maneuver. This one is from the Economic Times. Hypersonic missiles do not follow a predictable arc like conventional missiles, making them much harder to track and intercept. This one is from GAO. Unlike ballistic missiles, which reach similar speeds but have a relatively fixed flight path, the warheads for hypersonic glide vehicles, ... So you get the idea, right? These quotes create the impression that while hypersonic missiles may maneuver and lead to unpredictable targets, other missiles do not maneuver and lead to predictable targets. And that's simply wrong. Our report shows that, in fact, the majority of the missile threat includes systems that have maneuverability capabilities. So, Steve, as you've mentioned, you've been working on missile issues for almost 3 decades. Does this problem, this misperception about the broader missile environment extend to those communities as well?
Yes, I'd have to say they do, Sam. And I think that the best way to state it would be to say that we all are somewhat limited to the language we have available. And as a consequence, these terms like ballistic missile and hypersonic missile and cruise missile are really deeply rooted within the government defense and policy communities, as well as the public domain. And where the risk is highest from my experience and perspective is in the generation of the requirements that guide the construction of the responses that we'll build in the future to accommodate this threat environment. So essentially, we're in a position where we're trying to create and define ways to address the 21st century threat with a 20th century vocabulary, essentially. And these old labels simply don't do the work that we need them to do anymore. And in the meantime, the threat environment is continuing to rapidly evolve, quite rapidly, in fact, just like any other technology-driven ecosystem that we hear so much about in the news, like cyberspace, for example. So that was the principal motivation for coming up with a new way to address this threat, to characterize it broadly for the purposes of having all the right discussions at the right levels, and also to develop a construct and the tools associated with it that helps us apply this new think to the problem.
Perfect. Excellent. These, as you said, these old labels, ballistic, cruise, they're not helping us anymore. Hence the need for a new construct. Steve, why don't you walk us through the basis of this framework that we propose in the paper?
Well, to really escape the trap of these old labels myself, it was very important to back up as far away from the problem as I could and try to address the very simple question, what are the fundamental elements of missile systems in the 21st century? And I discovered when doing that, there were three, and they were fairly straightforward. And really, I couldn't divide the threat into anything more than some combination of these three elements. The first, I think, well, we all can agree on, is that a missile system is the combination of a booster and a weaponized payload of one sort or another. The second is that these weaponized payloads fall very distinctly into two bins. Either the payload is able to maneuver aerodynamically after boost, or it isn't. Everything falls into that in a binary fashion. And then the third is to say that these warheads can also be powered. These payloads can also include a propulsion system of some sort. And that is independent of whether or not the payload is aerodynamic or ballistic, for example. And when you work these through to their fruition, if you combine them, you end up with a set of 5 payload categories that capture at a top level the maneuverability capabilities of the payloads of the spectrum of threats that we face today.
Excellent. Great segue into some cool animations we have to show you. So we are going to now look at animations for each of the 5 categories. The first category are the classic ballistic missiles. Steve, why don't you introduce this category 1 animations?
Sam, category 1 captures what I believe, typically think of as the purely ballistic traditional missile. The proverbial example of that would be the Scud-B, the ancient Soviet-developed missile system, very simple. It's been operational since 1957 and widely proliferated to many countries, most of which no longer look on it very favorably in terms of military utility. In this case, for a purely ballistic missile, the the fate of the warhead is determined at the end of the boost phase of flight. Once that booster stops burning, the only forces acting on that payload until it hits the ground are gravity and maybe a little bit of drag, and that's it.
Yeah, well said. And Steve, I would just note here that if you look up the definition of a ballistic missile, whether it's Merriam, whether it's Arms Control Association, or various other sources, this is what you get. The definition of a ballistic missile is something that relies on initial propulsion, just like a cannon. So now I want to move to Category 2 systems. Steve, I have a couple more quotes I want to read because the Category 2 systems, some of the common examples are what people call ICBMs, and people are mischaracterizing ICBMs as well. So here is a quote from the Atlantic Council. ICBMs follow a predictable trajectory, so a target can be discerned after a launch is detected. And that was in a recent primer on hypersonic weapons. This one is from Defense IQ. Rather than leaving the payload at the mercy of gravitational forces, as is the case for traditional ICBMs, the warheads for hypersonic glide vehicles, ... And we, of course, know that's not true. Steve, how wrong are these quotes?
Well, since most of the ICBMs worldwide are MIRV systems, that is payloads, they have payloads that are multiple independently targeted reentry vehicles, then I would completely agree that there really isn't much ballistic about today's ICBMs. The ICBM we use today is one booster and one propulsive system, like a typically called a post-boost vehicle, that delivers multiple payloads, multiple warheads, I should say, onto multiple different separate trajectories to multiple targets. And those targets, as you can see in the video, 3, potentially more, could be Chicago, Little Rock, Arkansas, and Houston, or New York, Washington, D.C., and Atlanta. There really isn't much to glean from the booster to help you predict exactly where these targets, where these RVs are going, or when they'll get there. And while the RVs themselves may be ballistic, the system as a whole doesn't behave ballistically. This post-boost vehicle is burning, as you can see in the video, after boost in different directions, delivering RVs onto several different trajectories. So it's a one-to-many sort of an event.
Right. I would say the difference between New York and Atlanta is not immaterial. So
no, it's a strategic difference.
Yeah, precisely. Okay, so now we've gone through the ballistic systems. We've now included systems that are ballistic plus impulsive propulsion. Now we're going into Category 3, which are payloads that can maneuver purely based on aerodynamic capabilities. Steve, why don't you walk us through the Category 3 animations?
Right. We have 2 videos to show here just to try to capture some of the trajectory variability that systems like this can demonstrate. And here, I think the most important thing to do as you watch this video is to not associate any of the labels you might be familiar with, such as hypersonic glide vehicle or maneuvering reentry vehicle or aeroballistic missile, because the intent here is to capture the fact that regardless of that, and of course the behaviors of all of those are very overlapping, what you see is an aerodynamically maneuvering payload. After boost, in the first video, you see that the payload happens to not leave the atmosphere. It doesn't get out of above the tangible atmosphere, out into exoatmospheric flight. So it's essentially gliding almost continuously after the boost phase of flight, all the way to the target. And from that trajectory alone, you can't identify that as an aeroballistic missile or a MARV or an HGV. It could be any of the above. Now, in the next trajectory, to show a little bit of a different twist on things, it's also quite possible that the same is true for a trajectory in which the booster does loft the payload up out of the atmosphere into a ballistic arc that is followed by maneuvers of this aerodynamic payload after it re-enters. And those maneuvers might involve a MARV or an HGV, for example. So in both cases, the payload is purely aerodynamic. There's nothing else going on. But beyond that, we're not able to distinctly identify that it's an HGV or a MARV or some other vehicle beyond the fact that it's purely aerodynamic.
Excellent, excellent. Okay, now we're getting into really exciting stuff in the categories. Category 4 is very interesting. This combines the impulsive propulsion maneuverability with the aerodynamic maneuverability. So combining the maneuverability capabilities you see in categories 2 plus 3. Steve, talk to us about category 4 and the animations we have for category 4.
Category 4 is an important category because we don't historically have a convenient term or label to simply apply to it that we think we all will understand when we're talking to each other about it. This is obviously, as Sam has mentioned, it's the combination of the kinds of payloads that would be accommodated by category 3 that are purely aerodynamic, in addition to a propulsive system, an impulsive propulsive system that operates only over a very short period of time after boost. And in order to try to capture the vast array of trajectories that a system like this can perform, we've put together 3 videos. The first shows a case, all of these, by the way, have the same booster. The trajectory for the boost phase of flight is identical for all 3 of these. And the post-boost configuration that we're illustrating here is the use of a small kick motor that burns after boost somewhere above the tangible atmosphere and then delivers the aerodynamic payload further downrange or anywhere it like, really.
Now, in this first case, this kick motor burn occurs shortly after the end of the boost phase of flight. And the result is an extension in range. You can see the payload arc going well past where the booster re-enters.
As the vehicle re-enters, it pulls up and begins to maneuver and can maneuver for long distances potentially. And that may be doing so, very, very likely is doing so at hypersonic speeds. Now, in the second animation, what you see is a little bit different. Here, this kick motor creates its own apogee. It burns through apogee, steers through apogee to create its own peak altitude, and then delivers the aerodynamic payload, the rest of the payload, down into the atmosphere, where it then begins to do the same thing. So it pulls up, begins to maneuver a variety of different ways, potentially. Now, this is dramatically different than the first event that we saw, in that, for example, instead of a range extension like we saw last time, we now see a range reduction, much of which is then potentially negated by the maneuvering of the payload. And in fact, in this case, the booster re-enters and impacts farther downrange than the warhead does. Now, in the third case, in this third video, same boost phase, same kick motor, but the burn of the kick motor is delayed until after the whole combination has reached the peak altitude or the apogee of the trajectory. And on its way down, now this kick motor burns and adjusts the trajectory slightly, and then sends this maneuvering payload into the atmosphere, where it again maneuvers on its way to the target. Now, keep in mind that with a kick motor like this, or any other propulsive system like that's got the delta V, the change in velocity, the capability to deliver ideal velocity to the trajectory, to the payload, can burn in and out of the plane. It can burn in any direction it would like to. So there's the potential for the boost phase to really be quite meaningless in this context. The kick motor can change the direction of flight as well as the range at which the RV re-enters and then begins its maneuvers. So a very complicated, very versatile system.
Yeah, absolutely. And in the paper, we note that this combination of impulsive propulsion plus aerodynamic maneuverability, this exoatmospheric and endoatmospheric capability, could be really valuable for things like, anti-ship missiles or precision strike. Steve, one question I want to ask for you is, just to clarify, this we talked about. You talked about gliders and MARV systems in Category 3. Those systems could also be, what people sometimes call HGVs, could also be in Category 4. Is that right?
Yes, absolutely. And we need to be aware of that sort of this lingual blind spot in which we have a history of not combining those two things together. We tend not to have a way to just trigger something in our minds that makes us think about it's just a missile system that might have a propulsive element to it, as well as an aerodynamic element that operates separately, but produce trajectories that are very unpredictable. And in fact, I think a fundamental thing to think about here is that when you hear discussions about precision strike missiles or anti-ship missiles, well, most particularly precision strike ballistic missiles or anti-ship ballistic missiles, you can be sure that those systems are not behaving ballistically. The reason is that in order to achieve those missions, in order to perform those missions successfully, where you have to hit something that's potentially moving at long distances, you have to have the capability to maneuver after the boost phase of flight. So by definition, you are not flying a traditional ballistic missile. In the case of a Category 4 system, for example, you may use this upper stage, this kick motor, to do some fine adjustments, based on what you know about the motion of the ship since you launched. And then the aerodynamic capabilities of the rest of the payload, whether it's a MARV or whatever it might be, has the ability to then precisely steer aerodynamically to hit the target.
Right. Well said. The misuse of these labels, it makes me so annoyed, Steve. I almost want to go ballistic. Bad joke.
That's awful, right, man. That's just awful.
Stick to writing paper, Sam.
You had to do it.
Steve, Category 5. This is the classic cruise missile category, sustainer propulsion. Walk us through these animations.
Just have one here. What's important to bring out here is that I think historically, when we think of cruise missiles, we don't think about the fact that it may require a booster. Cruise missiles we often think of as, subsonic, slow, with loitering capability, fly for long periods of time, all of which could be true. But as technology has progressed, we've overcome the obstacles associated with supersonic flight and hypersonic flight using scramjet, which would be associated with hypersonic cruise missiles, or a ramjet with supersonic cruise missiles. These are air-breathing engines or sustainers that are, like the propulsive capabilities in Category 2, are active after boost phase is complete. But the difference is that these can potentially operate almost continuously after boost, providing acceleration and the ability to maneuver much like an aircraft. As you can see from the video, quite maneuverable. However, what's important to remember here is that as we increase the velocity regimes that we're operating in with cruise missiles, supersonically or hypersonically, ramjet and scramjet engines have to already be traveling at several Mach for the engine to even start and operate. So to provide the right initial conditions for operations of these higher speed missile systems, we have to deliver them with a booster. I suppose you could put them on the bottom of something that's piloted in a supersonic aircraft, but we aren't going to be able to do that for hypersonic cruise missiles or even higher speed subsonic missiles. It's much cheaper, much easier to do it with a booster. The result is that what we historically think of as cruise missiles are really part of this spectrum that we've just described. It's a weaponized payload delivered by a booster. And what this does is it allows us to include cruise missiles into this spectrum we're all working very hard to find ways to accommodate, instead of, as we have done historically, cleave it off and apply essentially a different set of terms to describe it and handle it differently, often by different organizations. It's really not the way that the most effective way to go about that. It's all part of the same spectrum, and this helps us to address those historical concerns.
Yeah. Well said, Steve. And just to foot stomp, that word spectrum, right? The readers of our paper would be wrong to sort of just replace, the terms of our categories for these old labels. Our point is that these are not sharp distinctions, as opposed to what I think is some classic understandings of what is a ballistic missile versus what is a cruise missile. Steve, the maneuverability capabilities is only, of course, part of what makes a missile system a missile system. There's also range. How does range fit into this construct?
Right. Now, that turned out to be the easy part. What we did is essentially take the best of the old and combine it with the new. Historically, obviously, we all are, I'm sure, aware of the established ballistic missile construct that breaks out ballistic missile systems by range class: close range ballistic missiles, short range, medium range, intermediate range, and intercontinental range ballistic missiles. So those range classes are appropriate.
And as you can see here, Category 1 in blue
are the ballistic missiles, whereas everything else, although they are often historically, particularly in categories 2, 3, and 4, are historically referred to as ballistic missiles, are in fact not behaving ballistically. Only Category 1 does so. So you could take a matrix like this and apply it in a number of different ways to include, say, looking at the way the missile systems in Russia today behave. And when you do that, what you discover is that there are no active Russian missile systems in Category 1. In other words, Russia doesn't operate ballistic missiles, which is an important sort of message to get across in the context of how we're going to effectively deal with the threat from Russia or China or any other adversary.
Yeah, that's absolutely right. I mean, when you think about the fact that, going back to the beginning of our talk, that, hypersonic weapons are being constantly compared to ballistic weapons. Well, what's the real utility of that? If people who are comparing them are thinking of what the definition of a ballistic missile is, if Russia doesn't even have a ballistic missile, it just shows that these gaps between the reality and the perceptions about the broader missile environment. Steve, we're about out of time. I could hear my daughter has woken up, which creates a harsh deadline for me. But I do want to ask you about arms control. There's a lot of focus right now about New START and about future arms control treaties, even moving beyond New START. What to you is a major takeaway of our paper for folks who are going to be thinking about arms control policy in the years ahead?
Great question. There are two very important things. But first, I'd like to say that let's keep in mind that the New START Treaty, as it's written, is itself predicated on the assumption that the missile threat, in a bilateral sense, in Russia and the United States, still predominantly behaves ballistically, which isn't really true anymore. or nor has it been in the context of ICBMs for quite a long time, at least in the bilateral sense. So there really are two things I think, that need to be emphasized. One is, don't get trapped by the old labels. Don't get trapped by what perceptions about what a ballistic missile is, what a cruise missile is, or what a hypersonic missile is. Avoid those. Look at it from another 20,000 feet of altitude using something like the missile threat matrix and say, okay, here's the threat we're really dealing with, whether it's in a multilateral sense or a bilateral sense. And then second, I think it's very important to find a way to incorporate the capabilities, the maneuvering capabilities of the threat environment into the language of future treaties in some way. That's going to be essential for the success of our negotiations going forward.
But it was also a good opportunity to plug the fact that you, Steve, and we are actually beginning a new project thinking about this question, thinking about some arms control considerations given the diversity of the missile threat. And so stay tuned, everyone, for that project. Steve, it's a real pleasure to talk to you today. As always, you and I worked on this project for over a year and a half, and you've been leading this technical work for decades. It's a real pleasure, and thanks again for walking us through these animations. With that, I guess we can hand it back to Rebecca.
A big thanks to Sam and Steve for that interesting discussion, and thank you to our production team, James Liggins and Sarah Pannoni, located in the Los Angeles area. As always, check us out on Twitter. We're at #TheSpacePolicyShow, and sign up for the latest news alerts at aerospace.org/policy. Tune in next week for an episode on innovative technology coming out of the Aerospace Corporation that just might change the way we think about space and what humans can achieve there.